This video covers what each of the three results analysis sheets show, how to use them, and gives examples of the types of questions they can answer. The results component of each sheet is divided into panels. For example, A, B, and C. This is a common format used throughout LCA Quick, with the graph and table names corresponding to the alphabetical code of their respective results panel. The summary analysis sheet. This sheet is where you enter general information about your project building design. This is used to compare your building to the selected reference building at the overall building level. Your first task is to select an appropriate reference building. This selection is automated by LCA Quick. It is based on the information you enter in the building information panel located on the results summary sheet. LCA Quick, the cells highlighted yellow require you to enter an input, whereas the drop-downs provide a range of predefined options which one must be selected from. The result graphs and tables are also controlled via selection panels with input cells and drop-down menus. Different drop-downs allow the user to select specific environmental indicators and life cycle stages to analyze. Another drop-down controls the normalization of these results. These divide the results by the different building factors entered in the building information panel on the summary analysis sheet. The environmental impact results shown on the summary analysis sheet all show overall building level analysis. Graph A shows the percentage difference between the building design and its equivalent reference building for the listed environmental impacts over a 60-year building lifespan. Table B shows the tabulated data Graph A plots, and Graph C shows environmental impact divided into its 7 contributing life cycle stages, comparing the building design to its equivalent reference building. These graphs and table can be used to answer such questions as what the environmental impact of the building design is, does the design perform better or worse than the reference building, and which life cycle stage is contributing the highest environmental impact over a 60-year lifespan. Answering these types of questions helps to identify the areas, e.g. the life cycle stages and impact indicators, where environmental reductions can be made. Further analysis in the other two result analysis sheets assist in refining the changes that must be made. The material analysis sheet analyzes the environmental impact of building materials used throughout the building's 60-year life cycle. These materials can be analyzed on an individual material level or higher up at a building element or BIM object level. The master selection panel, located to the left of Graph D, controls all the results shown on this sheet. This is where you select the environmental impact indicator, life cycle stage, and results normalization unit that you use to analyze your design's material impacts. Graph D shows the top 10 environmentally impacting building materials based on the indicator selected in the selection panel's drop-down menu. These materials are ranked from highest, e.g. having the largest total environmental impact, to the lowest. Each bar shows each material's environmental impact separated into the individual life cycle stages, A1 to A3, A4 to A5, B2, B4, C1, and D. Building material analysis. As the user, you select a material from table D1's drop-down list. This populates the table with the largest corresponding BIM objects that contain that selected material for the environmental impact lifecycle stage and normalization you selected using the master selection panel. The materials populated are ranked 1 through 5 in order of the largest environmental impact to its smallest over 60 years. Building material analysis. This table follows the same process as table D1, but populates the top 5 ranking CBI objects instead of BIM objects. Graphs E and F. These graphs show the top 5 environmentally impacting CBI objects and BIM objects respectively. This is for the selected environmental indicator for life cycle stages A1 to A3, A4 to A5, B2 and B4, C1 to C4, and D over a 60-year building lifespan. Tables E and F. These show the largest contributing materials in a selected CBI object or BIM object that you select using the drop-down list located in each table. The values populated are for the selected environmental impact, life cycle stage, and normalization unit you selected using the master selection panel. Table G1, Building Element Analysis. This table shows the top 10 environmentally impacting building elements based on the indicator selected in the selection panel's drop-down menu. These materials are ranked from highest, e.g. having the largest total environmental impact, to the lowest. Each bar shows each material's environmental impact separated into the individual life cycle stages, A1 to A3, A4 to A5, B2 and B4, C1 to C4, and D over the building's life cycle of 60 years. This information is plotted on graph G1. The results shown on this sheet can be used to answer such questions as which materials have the largest environmental impact, and for a specific indicator life cycle stage, which are the largest contributing BIM objects, building elements, or CBI objects that contain a specific material. Answering these types of questions identifies which materials may be substituted for lower environmentally impacting alternatives, such as substituting ordinary Portland cement concrete with concrete mixed with a ground granulated blast furnace slag, or GGBS, or pulverized fuel ash or fly ash cement replacement. The Energy and H2O Analysis Sheet. The Energy and H2O Analysis Sheet shows the environmental impact results of the building's B6 operational energy and B7 water use life cycle stages. This sheet also has input panels for calculating the environmental impact of renewable photovoltaic panels and water-saving measures such as rainwater harvesting and grey water recycling. Graph H, Building Operational Energy Analysis, compares the design building to its equivalent reference building. It plots the environmental impact of the operational energy use consumed over a 60-year building lifespan. The total consumption is separated into three contributing energy sources: natural gas, grid electricity, and renewable photovoltaic generated electricity. Like other LCA Quick results, the environmental impact and normalization units are selected using the master selection panel located on this sheet. Graph I1, Building Operational Energy Analysis. This graph compares the design building to its equivalent reference building. It plots delivered energy, not primary energy. Delivered energy is the energy consumed on-site at the building's location. The plotted consumption is separated into its three contributing energy sources: natural gas, grid electricity, and renewable photovoltaic generated electricity. Graph I1 always shows energy use in units of kilowatt hours, which is not a measure of environmental impact. Graph I2, Building Operational Energy Analysis, also shows delivered energy comparison between the building design and a reference building. This graph separates energy use into its energy end-use categories, so you can identify specific areas to reduce energy consumption and therefore environmental impact. These graphs and tables can be used to answer such questions as which energy end use has the largest environmental impact, and which energy end uses use the most energy. Calculating operational water use. The operational water selection panel is used to calculate the environmental impact of life cycle stage B7. There are three inputs: annual water demand, annual rainwater harvesting supply, and annual grey water recycling supply. The annual water demand is a figure that you must calculate separately. However, if you do not have this information, LCA Quick does provide benchmark values in units of kiloliters per net lettable area per year. The rainwater harvesting and grey water recycling supplies must also be calculated separately of LCA Quick and entered here. Graph J, Building Operational Water Analysis, shows the total operational water impact comparison between the design building and a reference building. This graph separates total B7 impacts into wastewater and tap water end uses. The use of water conservation measures reduce the impact of these two end uses.